All right, this is the energy exhibit. It's pretty much all done now, except for the labels. And we decided we would wait until we let some users play with it for a few times, figure out how they wanted to interact with it before we actually put labels on it. So, but the basic concept is it's an energy trail. And we follow the energy from the beginning to the end. Now the energy gets put into the system by the work you do to raise the ball from the base here up to the top here. That work is equal to the weight of the ball times the distance you lift it. Up here, the ball has potential energy. It's not moving, there's no kinetic energy, but it does have potential energy. It's got the ability to do work and convert some of its energy into other forms. The ball rolls down the track, down to the bottom here, and there's an electric eye that measures its velocity. Its velocity is related to the amount of kinetic energy it has. So at this point, all the potential energy has been converted to kinetic energy. We can read out the velocity on the display here and get an indication of how much kinetic energy it had. The ball then rolls up the other side of the track to the top over here, where it's converted its kinetic energy back into potential energy. You can see that this side of the track is lower than this side of the track. That's because we lost some energy due to friction. Over here, the ball rolls off the end of the track, rolls into the bucket. The bucket drops down, converting its potential energy into the kinetic energy of the bicycle tire. And then we can take this generator here, rub it against the wheel, and the generator converts kinetic energy into electrical energy that lights up the navigation lights on the yacht over here, which you can see if I spin it by hand, and you can see the lights light up. All right, now we can run it through its run here. We'll start up here, let it go. We'll let the bucket go to the bottom, and then we'll light the lights. And you can see, or maybe you could see, maybe you couldn't, but the lights only stayed on for a very brief period of time. And the reason for that is that we really didn't put that much energy into the system. To put it into perspective, the amount of energy it took to raise the ball from the base up to the top here is equal to 1/2000th of the energy in one tic-tac. So we're really not dealing with a lot of energy, and that's why the lights only stayed on for a little bit. But there you have it.